Hi, good morning to one and all. My name is M. Madhukumar Reddy. We are from batch 4 and our project on design and evaluation of interleaved boost converter for electric vehicles applications. Under the estimate guidance of Dr. S. Professor and the head of the department, Dr. R. Murugesan sir. Coming to the content, there are abstract domain introduction, existing system, proposed system, comparison between existing system and proposed system, and next basic simulation diagram, finally results. Coming to the abstract, nowadays electric vehicles have gained popularity due to their eco-friendly in nature. The project discusses the types of electric vehicles with the charges types and power levels. The battery of electric vehicles and fuel cell electric vehicles, fuel cell hybrid electric vehicles, plug-in hybrid electric vehicles. Some electric vehicles are there in now used in the nowadays. In a furthermore, the AC to DC converters are various DC to DC converters to operators that are essential for the EV chargers are explained explained with their pros and the consequences. The result shows the designed and the analyzed in the MATLAB Simulink environment. They are more suitable for the compared to the conventional DC to DC converters. Coming to the domain introduction, the development of electric vehicles has gained significant movement in the recent years, driven by the global shift towards the suitable transportation. The design and evaluation of interleaved boost converter uh, for EV applications plays a crucial role in the enhancing with the overall efficiency and the performance of electric vehicles. Designing the interleaved boost converter, especially specifically EV applications, involves addressing unique challenges and requirements. Coming to the design consideration, voltage and current capability, the IBC must have designed to accommodate the specific voltage and the current requirements of different EV models, ensuring the standardized charging solutions. Coming to the safety features of electric vehicles, there are incorporation of safety and features such as current protection and temperature monitoring and short circuit prevention ensure the protection of both interleaved boost converter and connected to the EV. Coming to the existing system, the boost converter is a type of DC to DC converter that steps up the input voltage to the higher output voltage. It's widely used in the various electronic devices, power supplies, and the renewable energy system. The boost converter is a value valuable for EV applications. There are suitable higher voltage is required, such as in battery powered devices, LED drives, or when interfacing with the systems that requires the higher voltage than the available input. The circuit diagram shows the one inductor and the MOSFET and diode and capacitor connected to the load. Coming to the block diagram, there are power grid and rectifier, DC power supply and the boost converter and the load. The power grid comes to AC supply is given to the rectifier, power grid to rectifier. The rectifier converts the AC to DC supply. There are some variable DC comes to the DC power supply. They can convert the variable DC to fixed DC supply. Next, we can connect the boost converter next to the load. Coming to the existing system disadvantages, there are some disadvantages are there: voltage stress and complexity, efficiency variation, and the output ripple. Coming to the proposed system, an interleaved boost converter is a power electronics circuit that consists of a multiple boost converter stages connected in parallel. Each boost converter stages operates out of phase with the others, sharing the load and contributing to the overall output voltages. This interleaving of converter is done to distribute the current power across multiple phases, ensuring the several benefits. Coming to the proposed system circuit diagram, there are multiple phases of inductors and MOSFETs and the diodes are connected in parallel. Coming to the proposed system block diagram, there are power grid to rectifier to DC power supply, DC power supply to the interleaved boost converter next to the load. The power grid connected to the rectifier. The rectifier converts AC to DC supply. There are variable DC comes to the DC power supply. They can convert DC variable DC to the fixed DC. Next we are connected to the interleaved boost converter, then to the load. Coming to the interleaved boost converter operation, interleaved boost converter is a simple terms. The interleaved boost converter is a type of power converter that combines multiple boost converters to increase the power output. Here how this interleaved boost converter works. Coming to the input voltage, the converter takes to in a lower voltage input to the, it can boost to the higher output voltage. Switching operation. Coming to switching operation, the converter uses multiple switches that operates in a interleaved boost manner. This means that the switches are turned on and off in a sequential pattern, distributing the load across the switches. Next to the inductors and the capacitors. The converter uses the inductors and capacitors to the store the transfer energy. The inductor helps the store energy during the on state. When the switches, while the capacitor helps smooth out voltage operation. Coming to the control circuitry, the converter also includes a control circuitry that regulates the switching of the switches based on the input to the output voltage levels. This ensures the output voltage remains stable and within the desired range. Coming to the proposed system advantages, the proposed system advantages are increased power handling capability, improved input and output filtering, reduced input and output capacitor stress. Next, uh, next coming to the difference between comparison between existing system and proposed system. Coming to the existing system, there are used for the lower applications. Proposed system used for the higher power applications. Existing system is a only single inductor and a switch and the diode is used. In a proposed system, multiple inductors, multiple switches and diodes are used. Coming to the existing system, switching conduction losses are more. Coming to the proposed system, switching conduction losses are less. Next, electromagnetic interference is more in the existing system. Electromagnetic interference is the less in the proposed system. It has a lower performance and efficiency in the existing system. It has a higher performance and efficiency in the proposed system. Coming to the results, waveforms of interleaved boost converter with the 20% duty cycle. The duty cycle is the ratio of on time to the total time of on switching period. It means that one switch is on for 20% of the total switching. The period off of the remaining 80%. Next, coming to the interleaved boost converter of 80% duty cycle. For the 80% duty cycle, the switch is on for the longer duration compared to the lower duty cycle. During the on time, the input voltage is applied to the inductor, causing the rise in the current. During the off time, the inductor discharges and the energy is transferred to the input. Thank you for giving this opportunity.